Happy Holi! Let's make a bonfire of our negativity and bring a color of positivity into our life. Wishing you health, wealth, and share of happiness on this Holi. Welcome back. In my earlier video, I had discussed about Riemann integration. I had seen what is upper sum and what is lower sum of Riemann integration. Today at first I will just recall this definition again. Just see. A partition P of the closed interval AB is a finite sequence x0, x1 up to xn of real number with the condition a equal to x0 less than x1 less than x2 up to xn equal to b. This is the partition of the closed interval AB. That means this is AB line, and here which is partitioned by a equal to x0, x1, x2 up to xn equal to b. Okay? And suppose f is a bounded function on the domain AB, and let capital P be a partition of closed interval AB. Then for each subinterval, here the subinterval denoted as closed interval xk k minus 1 to xk of the set. In this subinterval, first see the graph. Consider this is AB, and consider this subinterval xk minus 1 xk. Function is defined as look like. Then in this subinterval, capital Mk equal to supremum of the function, where x belongs to closed AB and small mk be the infimum of the function where x belongs to closed AB. That means in this interval, this value it would be small mk and this value would be capital Mk. Are you getting? I have defined the lower sum and upper sum, which is actually the each rectangle in the subinterval. I have defined the lower sum of the function f with respect to partition as LPF equal to all summation k equal to 1 to n small mk times the length xk minus 1. That means this is the height of the rectangle and this part be the width of the rectangle, and UPF be the summation k equal to 1 to n capital Mk times xk minus 1. Just see the picture. This rectangle be the lower sum in this subinterval, and this rectangle be the upper sum of this subinterval. Now I will define the Riemann upper integrable and Riemann lower integrable by the concept of Riemann upper sum and Riemann lower sum. At first, consider the set all UPF in all partition P equal to capital script P denoted as all partition P of AB, and infimum of this set is called Riemann upper integrable, which is denoted as integration a to b bar f. Since this is I have defined as Riemann upper integration, that means if we consider many type of partition then infimum of the set all UPF is called Riemann lower integrable, and Riemann lower integrable denoted as A bar to B if which is equal to before, but here supremum of the set all LPF where script P be the partition in the interval AB. Okay, and obviously this is two different set, but there exists some value where these two value would be same, and when these two value would be same, then we can tell f is a Riemann integrable. That means this is equal to at the point where the upper integrable and the value of lower integrable is same. Are you getting? Well, now I will see some geometrical meaning of Riemann integrable function. Riemann sum is, here I have defined just Riemann sum is, this is the height of the function fji, and this is the length of the function xi minus 1, where I varies from 1 to n. Here, this is actually the area of the rectangle, and here this n represents the number of sub-interval. Actually, this is imply the number of rectangle, and if we know the Riemann sum, then the Riemann integrable is a to b fx dx equal to actually limit n tends to infinity summation k equal to 1 to n f of a plus k delta x times delta x, where this part be the height of rectangle and this is the weight of the rectangle. Okay, and here this conception is, here I have taken the limit because when I will get more and more rectangle, then I will get the better approximation. When I will get the more and more rectangle, then the value of Riemann upper sum and lower sum will be same, because these rectangles are smaller and smaller and smaller. So there exists no error. Then I will get better approach when I will get limit n tends to infinity. Are you getting the concept? Why the Riemann integrable definition has defined as like? Okay, I will define the norm of the partition. This is the partition of the interval, closed interval AB. Norm means maximum distance of the subinterval xi minus 1. Here I varies from 1 to n. If we choose the partition n, then this is denoted as Pn. If we choose the partition n plus 1, then this would be denoted as n plus 1 such that. Are you getting the idea? Okay. So, by the concept of limit, we can approach as this is limit norm Pn tends to 0 summation k equal to 1 to n f of a plus k delta x times delta x. And here I have used non-Pn tends to 0 because if you increase the number of n, then the non-Pn will be decreasing. Are you getting? Why I have used this approach as for example, consider the integral 0 to 2 x square plus 10 dx. I will solve this part by this method. A to b fx dx equal to limit delta tends to 0 summation k equal to 1 to n f of xk dx, where f of xk equal to, just put the expression a plus delta x times delta x and limit delta tends to 0 means just partition. I can also use this as limit n tends to infinity. And here delta x since the partition. So this is actually, since here a to b, this is actually b minus a over n. Here this integration defined from 0 to 2. So this value would be 2 minus 0 over n. That means this is equal to 2 over n. First just find the value. Here a plus k times delta x means here a equal to 0 and b equal to 2. Just put the value. This value would be 0 plus k times delta x means 2 over n. Just put the value. This value would be 2 over n. That means this value equal to k times 2 over n. And if we put the value in the function, then f of a plus delta x times delta x means, since the function here defined as x square plus 10, so just put the value, then this would be 2k over n whole square plus 10 times 2 over n. Okay, and this is equal to just 4k square over n square plus 10 times 2 over n. Oh, this integral would be limit n tends to infinity summation k equal to 1 to n 4k square over n square plus 10 times 2 over n. Are you getting the main idea? Well, I will see how to check the function f is integrable. All of us know f is integrable on the set close interval AB means least upper bound of the set LPF where P be any partition, which is always similar to GLB of the set UPF where P be partition. This value is same for the integrable part. And from this relation, we can tell mathematically, let epsilon be greater than 0 be given, then there exists a partition P such that integration a to b fx dx minus epsilon always less than LPF. Also, for this, there exists a partition Q such that integration a to b fx dx plus epsilon greater than UQF. Okay? And this is denoted as 1 and this is denoted as 2. And since here I have defined partition B and here also defined partition Q, so consider P union Q denoted the common refinement of P and Q. Then, since P union Q be the common refinement of P and Q, so from 1 we can write A to B fx dx minus epsilon less than LPF and LPF less than LP union QF. Okay? And from 2 it imply A to B fx dx plus epsilon greater than UQF and which is also greater than UP union QF. Okay? And from these two lines, we can easily write UP union QF minus LP union QF less than 2 epsilon. Are you getting the relation? That means when f is integrable, then this difference should be less than epsilon. We all of us know UPF always less than LPF. But when the function will be integrable, then difference between UPF and LPF always will be less than epsilon. Now my question, is this relation is true for conversely? Conversely, if this condition holds, then obviously f is always integrable. That means this condition is if and only if condition. This is one way to find integrable of a function. Okay? Well, for example, consider the function f from AB to R and the function is denoted as fx equal to c, where c belongs to any real number. Here it means the function is constant function. At first, for this we have to partition AB. Consider a equal to x naught. The partition is look like x naught less than x1 less than x2, so on, xn equal to b. At first we have to find greatest lower bound of the function. Consider in the subinterval xi minus 1 to xi. Consider this subinterval xi minus 1 to xi. Since the function is constant function c, so consider this is. Then, so always capital Mi equal to small mi, which is would be actually c. UPF would be summation I equal to 1 to n mi times xi minus 1, and this value would be c times b minus a. Similarly, LPF would be, since capital Mi equal to small mi, so this value also would be c times b minus a. That means this rectangle here would be just trapezoidal type. When c greater than 0, then this type of picture, this type of trapezoidal, here the rectangle look like, and when c less than 0, then this type would be. Okay? Since the value of UPF and LPF is same, so obviously this function means constant function always will be integrable. And since the function is integrable, then the difference between UPF and LPF would be just 0, and this value always less than epsilon. Are you getting why we have to find any integrable function? Well, let's see the Dirichlet function. We all of us know the Dirichlet function. This is when x belongs to rational number, then the value of gx is 1, and when x not belongs to rational number, then the value of gx is 0. Now my question, is this function is integrable on the interval close 0, 1? Let AB belongs to real number such that A less than B. Then there exists T belongs to AB
such that t belongs to rational number. Also, there exists S belongs to AB such that S not belongs to rational number. And this is true for every sub-interval. And consider the partition P equal to x0 less than x1 less than xn. Here x0 equal to 0 and xn equal to 1. Be any partition interval close 0, 1. Then infimum of g on each sub-interval always will be, since the function is defined as like, so infimum always will be 0 and supremum similarly for every sub-interval always will be 1, since the function is defined as like. Okay? Since infimum is 0, that means all one rectangle will be height 0. So LPA for any partition the value will be 0, and this is true for all partition. And since all higher rectangle will be of height 1, so the value of UPA will be 1, and similarly this is also true for all partition. And since LPF not equal to UPA, so this function is not Riemann integrable on the interval 0, 1. Are you getting the idea? If you took epsilon equal to 1, then their difference UPF minus LPF would be 1, which is greater than equal to 1. Are you getting the idea? That means this condition also not will be satisfied since the function is not Riemann integrable. I hope my all viewers have understood what is Riemann integrable function. If you check on cell, you will see all constant function, all continuous function, differentiable function, all be Riemann integrable. Today I will stop here and I will discuss this part elaborately in my next lecture. See you soon. Stay safe and stay positive always. And don't forget to subscribe and to share my channel with your friend. Thank you so much.